to. Good. Hello, everyone. Welcome to this new discussion on our lovely community, because software craftsmanship community. An episode in which I will try to discuss how can we, some key tools to start profiling and looking into some performance issues of your application, like the beginner's guide. It's not intended to cover all these technologies in details, in all of their details. Three of them I propose to cover today. First is GFR, Java Flight Recorder, Java Flight Recorder. Now, this baby is a tool built inside GVM. Every GVM has it right there in it. And you can activate it either at the start of an application, or you can activate it after while the process is still running. And let me demonstrate one problem we could find with Java Flight Recorder. I have an application. The Git for this application, I will push it in the chat in both Zoom and YouTube. Yeah. The commit that is done just before this moment is the last one that you should look into if you want to reproduce this stuff yourself. And I've started Leaks application, start database, and start wiremock. Again, it's not how to put this. My goal is to demonstrate what you can do with the tools we have. All of the tools that we will see today are free. So we have we have an application started already. And let's assume that, let me just, one second. So this is export. Yeah, high school surprise profile. Good. So let's see. Let's call one endpoint. We bring some. So localhost 8080/profile me. Now, this one I'm sharing the screen. Oh my God, I'm not sharing the screen. That's quite stupid. Thank you. It's now sharing. I hope. Right. So I've called this endpoint localhost 8080/profile. This one returned after a while, but this is a slow endpoint. Let's first say that we know that we have such a slow endpoint. Let's start with that. If we have a running application that has some issues that we know they occur when a certain endpoint is being called, what you can do is using the command line, actually using a tool which is available in GDK called GKMD. This GKMD, if you just hit it, it will show you a list of the processes that are currently running. The one that I'm interested in is this one, Leaks app. So then I will say GCMD. This is available in your bin folder of any GDK distribution, of any Java SDK. So then 8792 gfr.start. Now, what else can you do after start as the parameters that you can give? Let me show you the cheat sheet, basically. Where are you? GFR. Good question. It was an MD. That's for sure. MD. GFR data. So you can start your GFR for a duration of 60 seconds. Afterward, it is automatically stopped. Or you can start it and leave it open. It's a different process. I'll see in a moment. And let's generate this file name right now. Let me check the file name. 8792. I think it's correct. And then this, and then file name. Let's name it like BSCC. Okay. And if you start it, you can do oops, no self process. 87. Oh, right. It's truncated somehow. What the heck? I think it's because of the sharing. Strange. So again, what is the Leaks app 8? It was a 4 in front of it. You're right. 4 in front of it. Good. Now the GFR recording is started indefinitely. It will be written to this file, and it is kept open. Now, if you reproduce the endpoint, hit it once, Okay. If you know the endpoint, I will show you what you do if you don't know which endpoint runs slow. Then you can then call the same GCMD PID and then stop. And the name, of course. Name equals, and the name is given to you at the beginning when you start the recording 1, name 1. It's quite strange if you ask me, but yeah, now it stopped this. This output of the GFR. So let me explain a bit the idea of GFR. Javascript Recorder is a tool which is built within the JVM. If you Google it and if you watch the people that created it, they brag everywhere that this is a tool that you can keep open in production, that it has a performance hit of under 1%, 1%, or even less than 1% performance hit. Using some advanced techniques like thread locals and binary storage, they can achieve very slow impact in your performance. So you can keep it open even in production. That's what they brag about everywhere. BSCC GFR. Now, what you can do with this GFR? There is a tool that you can download on the internet. It's called Java Mission Control, which is able to open the files produced by this here. And if you open the file, it will do automatically for you an automatic analysis. And in my experience, this is extremely useful. Most of the time, it points to the problem. This time, however, let's see. Oh, I didn't activate the necessary things. So let me show you again what you can do. The thing that I showed you right now is is something you can do by logging in with SSH to the server and doing the command line operations. Now, the alternative would be to start with GMC also. The problem that I just hit into is that I did not instruct the GFR to profile everything that I wanted. To do that, I should have said here, where are you? You can actually choose the profile level. Now, I don't have it here, but here are the links that you can use to find it more. The same thing that you can do via command line is available to you if you connect to it, to the process, using the Java Mission Control itself. So start file recording to connect to that process. And let's say start for 1 minute. And now here is the trick. There are two profile, how do you call this? Profiles. It's stupid. It's the level of detail, to the amount of detail they collect. The continuous one, they brag that it takes less than 1%. And this is what I started just now. You can, however, select profiling, which is just 2% overhead, according to their studies, and you can just start that. Of course, you can actually change these profiles, and you can add whatever here. This is a very deep stuff here in the advanced part. There are a lot of events that you can manually check. Most of them are enough. The profile setting, the one that takes 2%, is typically enough to get almost all the problems out there. Okay? Finish. If you do that, start it for 60 seconds. Now let's reproduce again the endpoint. I don't know what happened in there, right? I don't know what exactly is going on. So blindly looking at the code. Okay? Good, it finished. Let me stop now the recording. You can stop it here. This is available, of course, only if you connect to a local process. That's why I started with the GCMD, because you can use that with SSH. And still, there you go. Now, right now, this is this is a place in which there are problems. However, they are not yet visible because I only hit the endpoint once. Let me show you what can happen if that endpoint is hit in a continuous manner by multiple users. To do that, I will go to a stress test tool, which is called JMeter. Now, this project, JMeter JMX, is available in the same Git that I shared with you previously, right? Can we change video quality? I'm not sure what you mean by video quality, right? So I will comment this first one, and I will explain later what's this about. And in this part, I will say profile me. I will enable this profile me, and then I will start shooting with 2 threads. Let's put more here. Let's put 5 concurrent requests. in an infinite manner, shooting continuously to my server 5 requests at a time, right? The endpoint that I'm shooting is the same that I just accessed, okay? Let me run this now. This will cause 5 more many requests go to my application. In the meantime, they are now running in the loop continuously. In the meantime, I will go here and I will connect again with Flight Recorder using the profile part. So why did I not see anything previously? Because I did not have enough pressure on my application. I only had one call. And according to the automatic analysis of Java Mission Control, they thought it's not a problem right now. So let's wait a bit to get some requests piling up and some activity in my application. Okay. Again, I need to insist you can do this remotely also using SSH, connect to that machine, and then start the same thing that I'm doing here on a remote server. Then you download the GFR file to your machine and you open it with Java Mission Control. All of these tools are free, actually. GDK on the machine running the GVM. No, you need only the GVM. The GVM itself, it can be instructed to start recording. The GCMD. Let's have a look. Good question. I don't think so. I think you only need GVM. Let's see that. So the question was if I need a Java runtime or let's look in the runtime. To my knowledge, GCMD is a tool that am I wrong? Let's see. Yes, I'm wrong. There is no GCMD over here. You're right. So you need the GDK installed, not only a runtime. Yes, you're right. Now, let's see what we get over here. Still nothing. Method profiling. So, wait a second. Oh, yes, it's okay, actually. The most sample method, so this one is red, okay? But let me explain the other parts, which are red. Bytecode verification, I've disabled it explicitly with xverify none because I wanted my application to start faster. This is what I do in my local environment. It's not like that in production. Stack depth setting is because I use Spring. And because I use Spring, I have huge stacks and they exceed the maximum of 64 depth. And the Java Flight Recorder is somewhat, I mean, it had to truncate its stack traces when it snapshots what my application was doing. Then method profiling is red, and this is the only one, which is also this one. This one, it says that 47 of my processor is used by other applications. Of course, I'm streaming on Zoom right now. So this is why it's not happening, this one in production, of course. And on my same physical machine, other processors are eating processor. But it's so nice of it to show you that, right? Especially, maybe in a cloud environment, this could become interesting. Or maybe if you're deploying on a server on which there are other processes running, this can help you identify those. And method profiling actually pinpoints the problem. It tells that you are spending 99% of your time. So how does this work? It's like someone who takes snapshots of what your threads are doing at every single at a regular cadence, with a regular rate. GFR keeps snapshotting what your application is doing, and told you here that you are spending 99% of these snapshots are occurring while this method is running, which is amazing, but of course that's the only thing that I'm running, right? I'm cheating now. This is the only thing I'm running. So to make it more interesting, yes, make it more interesting, let me put some fog. What the heck is this? This is an endpoint not doing anything. But it's not, I mean, calling Hibernate persistent, marshalling JSON and doing stuff in the background, right? Let me show you what this fog is doing. Briefly, just very briefly. Fog. This is calling in the loop the following flow. It's creating a fog, getting the fog, updating the fog with some DTOs, deleting the fog. I mean, creating some entities to make some noise, to store something in Hibernate, to marshal something out, to merge something out here in the safe, right? Also converting from entities. There's quite a bit of noise happening in the background with this one. And the chain that I'm using, that I'm calling there, it's creating a fog, extracting the location that was created, the idea of the fog that was created, getting the fog out, updating, getting, and deleting. Okay, and these happen in a loop on 20 threads. Okay, this is more realistic, really. So let's start again. This one, I will start it right now, and I will go now to my Java mission control, JVM browser, connect to the same application, do the oops. Here I've clicked the wrong button. Start flight recording. I can't. It made the thread dump. Boom. So let's again, yes, that's it. I want profiling, finish. They will advise you to keep your GFR open in production for critical systems with continuous, with under 1%, because if something occurs there, you can have an analysis what happened. It's tricky. I'm not sure if I would recommend that in the open, but yeah. So let's leave it a bit and then let's close it. Let's see what happens now. Now, of course, it was 99% before, but because I wasn't doing anything else. But now it's much more noise in the application. I hope I'm doing the right things. That's what I'm really hoping. Let's see. There are a lot of moving pieces in here. So yes, that's better. So the 95% of samples happened while hashing match was running. What the heck? Now, the same GFR output can also be loaded and actually can also be acquired by pressing this little button over here. This little button is called, it means to start an application with the Java Flight Recorder connected. Okay, it's only available in Ultimate, but however, the display that it allows us, it's quite interesting. This is, unfortunately, you have to pay for that, but I will show you another version later, which is completely free, doing the same thing, basically. So the thing that I've captured with the Java Mission Control, or the thing that I would otherwise download from the production server, let's name it, this time is in the user, is in my user home. I will load it from my IntelliJ. Actually, you can load that from here. And let's look for BSCC. Good. Now, what IntelliJ Ultimate does by default, it displays you what's called the flame graph. It is the output of a profiler, basically. It tells you, so during those snapshots, those 2,600 snapshots, 100% when they snapshotted, they were running. I mean, imagine taking like thread dumps and doing snapshots of stack traces basically at regular intervals. Whenever those stack traces occurred, the do filter of the Tomcat was running. Of course, I mean, as a web application, that's what I'm doing really. And then if you go up, you will find that basically most of the time, to be honest, 94% of the total snapshots occurred while this method was running. So that tells us that this method takes a lot of time. And if you are curious to look into it, you will see that you actually do match. And this is what, let's see, jump to source, match. This match is doing a contains. Let's analyze a bit of what happens here. I'm receiving as a parameter two big collections that have 10,000 elements, 2,000 elements each. And what I want to do here is to intersect them. So what do? I create, I count how many of them match. That's it. I count how many of them match. And to do that, I iterate in one collection and I do if, and I contain in the other. Now, this works like hell because these are array lists. If, however, I would make them to be sets, as you know, the contains works in constant time in a set. So technically speaking, if I would make them a set, I will have far better behavior. And actually, I could actually cheat and say here, new hash set, like this. Almost hash set. I think it's enough like that to convert them once in a hash set. Waste a bit of, invest a bit of memory into having better performance later on. And then let's do that for all IDs also. And let's make this a set for that, so that afterwards this is. My God, what strange code appeared here? New set of what are these longs? I don't even know what these are. Okay, I don't really care. I just need to be a set. Good. They turn out to be what exactly? Strings, honestly. Good. So with this set, if I do set contains, and if I restart, the problem should go away. But however, I was able to trace a problem to some code that I did not know about, exactly the point where I saw that release contains took the largest part of my time, okay? So blindly, just by looking at some snapshots. Even though there were noise, there were other things happening in the system. If you look carefully into here in the profiler, you will actually be able to see those other things if you zoom in the proper place, if I'm not mistaken. Here. You can zoom, and I think process one, I'm not sure what these are, to be honest, but in here somewhere, there are the other endpoints which are happening right now, transaction servlet. I'd love to show you one of them, but I don't see them right now. Request facade, nope. You can search in that also, but I don't see them right now. There are other things happening in here which not even I don't see that one actually. Good, but anyway, I identified with some profiler tool that you can run in production even a problem like that. Let's see another case. Let me stop this for now. And let's now go to the export example. Enable. The same thing, the same idea, but this one a different kind of beast, something that only the GFR would ever be able to detect. So the system is the same, it's still deployed, but I will hit it with a different endpoint. Okay, again, with the fog activated, there is noise in the background, so that to make things more interesting. So let's run them again. I hope it runs infinitely. Yes, it runs infinitely. Good. And let's go to Java Mission Control, snapshot again, record what happens to detect a problem. If there is a problem, start recording. What's remarkable about this time, I need to be sure I put profile. You will see. This GFR, what's its best power is, first of all, you can activate and deactivate dynamically. Secondly, or even with SSH. Secondly, is that it goes very deep into the GVM itself. It can show you statistics about garbage collector. It can show you how many collections, how much time they took, young, minor, how long the pauses were. I'm using G1, which is not extremely fast as the new age garbage collectors today. It shows you a lot of interesting stuff, including stuff which are actually unavailable to any other tool. Now, I would like to show you now one of these things which only GFR can detect. Let's see if I'm lucky to show you now. The gods of the demos, the demo are with me. Yes, they are with me. There is an exclamation mark in here. Ooh, what is that? Let's see. I hope my machine will take all this pressure because it's a lot of stuff happening. And I should stop the JMeter. This is eating 25 threads of my machine, so continuously. All right, so let's see. TLab Allocation ratio. What the heck is that? This is one of those things that most people don't know in Java. TLab comes from thread local allocation buffers, is where the objects are by default allocated when you do new. And it tells you that your 95% of your objects are allocated in outside of the TLab. Outside of the TLab, this is very bad because it incurs synchronization penalties and it works far worse. It turns out that 5 gigabytes, my God. And you can display what threads allocated outside of the TLab, or better, what methods allocated. And it turned out that this one, unsafe allocate, something that you don't know yet. What is it? This one allocated 28 gigabytes outside of the TLab. What the heck is that, right? So you want to see what's the thread of that stack trace. And the good news is that it allows you to see, during those snapshots that it took, it allows you to see the allocated initialized. When did it happen, really? It happened, and now you find the first method, which is yours, export.memoryme. Okay, and even if you didn't know that the problem was there, you can go now to export.memoryme. Let's see what we found there. Export. Come on. And now you will see a problem that some people actually discussed in not high school, to be honest, But something very funny. Do you see this? Do you see this? This is the for concatenating the results in the database, which it turns out that the database initially had about approximately 10,000 elements or maybe 1,000 elements, and it was not a problem at the beginning. But then the elements grew to 50,000. And 50,000 elements, six characters each. If you concatenate 50,000 elements of 6 characters each, that size will exceed the thread local allocation buffer. And this plus equal will end up allocating at each iteration a string outside of the thread local allocation buffer, which is dramatic because it's 50,000 and the string grows at every iteration, it gets a new allocation. And this new allocation is done outside of the TLab, which is order of magnitude slower. So, of course, you can alt enter and convert it to a string builder, right? But I want to point out another thing. Even if you do a string builder, if you concatenate, so there is a common misconception over here. How many concatenations are happening here? 50,000, right? 50,000 concatenations. Now, I will put a string builder into here, but then I will add one more concatenation over here. What to do here? Actually, let's do the same, small dot name, that's it. Now, how many concatenations do I do now? 50,000, right? Because I'm doing a plus over here, and this keeps repeating every single time. It can't really know what small is. It can't do any optimization in this regard. Let's see what it says over here. Yeah, it says that you should chain the append. Of course, I can do that, but I want to show you one thing. Let's restart this and rerun the exercise. The problem is that actually your allocations went outside of the TLab. That's what made them extremely painful. Concatenating 2 strings of 6 characters is not a problem. Concatenating strings of 10 to 20 megabytes plus 6 more strings, that's a problem because the new string will not fit the thread local allocation buffer. So let's give it one more try. Perhaps I'm wrong. Let's see. Let's record again. But before we record, let's start the load testing. Record, load, and then leaks app, start file. All right. Finish. Already half an hour. Let's see. So recording 1%, 10%. Okay, 3, 2, 1, shut down. Let's close JMeter also. Let's come back to analyze what GMC acquired. Let's see. I should have showed you also. It's still allocating after the TLab. Why? I'm not sure why. Because let's see. TLab allocations. Is this the last one? It is. But compared to the previous one, 3 gigabytes, not 28 gigabytes. Now, why? Because as you know, string buffer also has to increase, right? String builder also has to increase as you write stuff out. And the memory will still be allocated, but not at such a high rate as before, right? However, let's do another optimization over here. Let's take as a parameter from Spring an HTTP servlet response. And on this response, as you may know, you can actually take the writer from it, because this is what I was doing, right? Get writer dot write, and I will write directly on the network, on the network socket, my results. I will not accumulate stuff in memory. Almost. Alt enter. Exception. Right. So now I will flush out of my memory the data that I am accumulating. I will not pile up a huge string in memory to write at the end. This is far better, streamlining, getting stuff out of your memory as fast as possible, but I'm still doing 50,000 concatenations. All right. So let's see. Will I see something bad happen or not? I don't have enough time to show the performance benchmark on that now this became extremely fast. I will have to trust me on that, because since I think it's already done. Yes. Is it restarted already? I hope so. Let's see. Is this closed? Yes. I didn't saw it restarting, so let's do it one more time. It should print the banner. Where is the banner? Oh. So concatenations with small strings are not painful, but concatenations with large strings are painful. That's why you don't want to keep them in memory, not even in a string builder or buffer or whatever. You just write them out on the network as soon as possible, or on the file. Open a file, write them on the file, get them out of your memory as fast as possible. Okay, that's a principle to follow every single time. Okay, let me close this because these take a lot of memory. These tabs. Okay. Now I started the application. Let me connect to it to Javascript Recording. I should start first the load. Doesn't really matter the order, but start by recording. Come on. We could spend half a day discussing the features of Javascript Recording. It's a lot. It's very, very deep. Should we get that to be wrapped into a buffer writer? No, it's already buffered anyway by the network adapter. So the network adapter won't be able to flush outside the data, but at the rate in which the network is behaving. So you buffering again yourself is not helpful. Actually, buffered writer is not helpful at all in any situation today, because we have SSDs, we have hard drives which are extremely fast, and writing them at random locations is not as painful as it was previously. So honestly, today I didn't see more than less than % improvements with buffer writer or reader. It's not really helping much these days. It was useful in the times that we had slow hard drives. There is no more thread local allocation buffer issues. You see, no more TLab issues. Why? I flashed outside as fast as possible the data. I could see now. I didn't show you the duration of this before, but the response data, it's empty. But that's a problem. Why is it empty? You try to write. I don't know why it's empty. Am I calling the export one? Yes. Response body. Not good. Why don't I see anything over there? Let's see the log. Is anything happened here? No. Get writer, write. Strange. Let's concatenate with enter. Although I don't. Yeah. And one more thing. Let's flush here. Flush buffer. Anyway, the point is made anyway. I'll give it one more try. Even if it doesn't work, I'll move on. Get writer, right. That should work. Oh, it's a get. It's okay. It should. We can send under response. Looks good to me. One more try, and actually this time I will try it from the browser. Export. Empty. Why is it empty? I don't get it. Plus, writer, right. I don't know what's wrong with this guy. Now, anyway, what I said still holds true. That maybe Flash. I tried Flash, but you didn't get it. What happens? Anyway, let's move to the next tool. So this one's Raptor buffer. I don't move. Yeah, but I flashed it. Close. What? Close the response. Okay, let's try that. But it's not like don't close it like that. Really. It's closed automatically. Doesn't matter. GD doesn't really matter. One single thing I need to check first. Do I persist the stuff? Persisting data. Yeah, it's there. Anyway, let's see the next one. So this was Javascript Recorder, somewhat low level. Shows you information about garbage collection, about this type of memory problems. You can trace stuff in the. Oh, so very interesting. Socket input output. How much time did you spend waiting for others, for example? On what port did you request the data? How much time did they took to respond you? Right? Quite interesting stuff. Quite interesting stuff. So I will definitely give it a try as a first tool, let's say. Good. I will close Javascript Recorder and move to the next tool. Okay. The next tool is somewhat more high level. It's a tool somehow built not on top, but it's extremely easy to use in practice. To demonstrate this tool, I need to experiment a. This one was 1 second. Not. Let's try this one. No. So there is here somewhere long. This is a doesn't work. One more chance. Long query. Is it long? Uncomment me. Just a second to start with this one is better. N plus 1. Good. Now, what is this? This is a search. This is a search displaying the parents with the children that they have. The children don't have any data in them. I didn't have time to put more, but there are 2 children. If you okay, this is a list with 2 children. Excellent. It's a list of 2 children. Perfect. And in here we have only 10 elements. Now, why 10? If you look at the implementation just a bit before we start, you can see that in my query that I access, I'm finding the parents requesting a page of 10 elements, and I respond with the page, basically. This is what happens over here. And as a consequence, I see over here, I have 14 elements in total, and this is just the first page containing 10 elements. If you count them, they are 10. Now, what's wrong with that? Well, let's put it in our JMeter, and let's actually call that duplicate first. Okay, enable. And let's call that n plus 1. If you know, the name is already self-explanatory, but maybe you didn't get the point first yet. So let's run this. It's a get, simple as that, together with the other stuff, okay, from above. Let's see what happens. Now, the tool that I will use, it's called Glowroot. And it's I've added it as a Java agent to my application. Glowroot. Let me point you to the website that they have. This is completely free tool, and it really saves our ass in some occasions, 2 occasions. This is the site, completely free. Download this, put it in your Java agent when you start your application. Of course, I wouldn't be very comfortable putting this into production, but to analyze some problems, it's really, really life-saving. So, localhost 4000 opens with the Glowroot. Now, I think I will stop JMeter because it already fired quite a number of requests. Stop. And let me show you what this presents. It shows you an overview of the time that was spent, total of time, the profile me in total since the beginning of its recording, and it was recording from the beginning. I could clear this, of course. I could clear the storage and start it over. But I will do this just a moment later. For now, let me run it through what it can do. The endpoints, which are the slowest endpoints, basically. This is that actually, which are the endpoints which consumed most of your time, in which your threads were spending most of their time, basically. Of course, fog is there because I'm hitting fog with a lot of requests. And also very interesting here, the commits, okay, how much time they took. Hibernate delete, Hibernate commit, this understands a bit of your technologies, right? And what I want to go to run it through is here. This one, in the queries, it displays to you the queries that were run. So this one intercepts the communication of your system with queries or other systems, okay? And what it does, it shows you that you have called this endpoint 260,000 times, but it's normal because that was the endpoint I was calling on 20 threads a lot of time, right? And if you scroll, actually, I should it's hard to beat 265,000. So let me delete all the data. Yes, all the statistics that it gathered, and let me run just for a moment the JMeter again with this n+1 and the fog tests in parallel. Okay, now let me stop and let's look what this one captured. Queries. All right. The first one is select children. 29,000 queries. In how much time? 10 seconds? 29,000 queries were ran. And this query looked like this. The same query 29,000 times. What the hell is wrong with you? In 10 seconds, what in the world? And then you look and you start looking around. What happened? And if you look at the load level, you will see that this one was called in 5 simultaneous threads in a loop. This one, n+1. But this is strange. Now, where does this occur? the next step for us, video quality unintelligible. Really? I'm sorry to hear that, but let's ask Netflix. Netflix says I have 500 megabits per second, so it's not on my side. Let me bring the microphone closer. See the microphone? Yeah, it's the right one. It's a big one, so it's not on my side. Anyway, so coming back to the discussion over here, we have this query which is running an indecent number of times, right? So what's the point? The next thing we should do is to activate the Hibernate logs to see where this query comes from, okay? Now, if I'm not mistaken, I was already, no, I did not activate it yet. I could, but okay, let's activate it to be as clean as possible. What I will do over here, I will insert into this P6 spy. If you know me, I'm a big fan of this tool. P6 spy, I've just inserted this part in front of my GDBC URL, and now I need to change the driver to point to P6 spy. Now, probably some of you don't know about this tool yet. Surprisingly, P6 spy is a jar you can put next to your application. Actually, our performance profiling team came with this tool and added this jar next to our application, included it in the class path, and just changed our GDBC URL from outside of our application and the driver class. And all our database interaction suddenly went through that P6 spy driver, which is printing basically all the GDBC interaction in the log. Now, I hope I didn't do a big mistake, because I have some tools that insert a lot of data at the beginning of the, oh my God. Wow, probably I did a big mistake. 50,000, you say, huh? 50,000, 50,000 inserts. That's not funny. So let's comment this one out, because otherwise that's the only thing we will see today. Once more. So P6 spy is actually intercepting the GDBC, and using it, you can find out what requests fired those queries over here. Okay. Right. You can also look in another way. Oh, while it loads, let me show you one more thing over here. Besides transactions, there is also not response service called thread profile. Yeah, this one. This shows you where time was spent. Remember when I told you that IntelliJ has this ultimate feature to with the profiler that we played, and I promised to show you an open source and free tool? This is it, Flame Graph. This is where your application threads spent their time. So IntelliJ isn't the only one using that, really. And basically, your time was spent in what? Actually, Prometheus. So we'll get to that in a short while. But your time isn't really spent anywhere. If you look closely, and if you spend time to analyze, or if you repeat this later, you will not find any issue in here. You will not find any issue because you are not processing a lot. You are not doing anything. You are basically just waiting for the database, really. But you are waiting for a database in a very short time frame. So to be, let's see, but perhaps I'm wrong. Internal, is there anything from Victor over here? Okay, this one is wasting a bit of time, but it's actually not wasting. It's just in flight doing stuff. It's nothing suspicious over here. So then in the queries, however, this one is strange. So now that I've restarted the application, hopefully successfully, yes. Let's see what happens if you, where are you? Here, n+1, enter once. If you just hit this endpoint once, what happens? It happens the most common performance issue in Hibernate. You are doing one select first to get the parent, and then 10 selects to get the parent children. Why? Because where are you? n+1 here. Because you have to serialize your parents, and your parents, when they are serialized by Jackson, contain a list of children. The children need to be serialized because I see them here. Even though they are empty, they are still serialized. So basically, the tool traverses your entity and causes lazy load under the hood. If that's what you want, probably not, but you found the problem, right? To fix it, I don't want to leave problems unfixed. So to fix that problem, as I discussed today with the group with the GPA training, to fix it, what you can do is to, instead of doing a find all with a page request, you should use, I'm not sure if I'm able to do that fast here. Let's give it a try. Select P from parent P. Left, that's the keyword, left join fetch P dot children, which will preload the children, where P dot name like question mark 1. That should do it. I'm not sure if it, let's give it a try. So parent, that should do it. Should avoid the queries, right? So what this can show you very, very, very rapidly is the query which runs, which either are repeated too many times, or the queries which are very slow. Works with Pageable. That's why I wasn't sure. Let's give it a try. Okay, and this one I need to uncomment that one, and prepare the next example. I will come back here to the version without interception because I will print a lot of inserts in there, 1 million or something. I will insert 1 million of stuff. So let's see now the version that we discussed. Actually, if I fire this request, how many queries will I see? Let's see if I'm right. Oh, it's still loading the parent. Why? Let's see. What am I doing wrong? So queries, right? P from parent. Left join fetch P children. So parent from parent. It didn't took the change. It does this. It fires the same select. The only possible problem is that I'm not calling the right query method. So let me see. Yeah, I'm not calling the right query method. Let me call this one. Okay, and let's call it ER. Or what the heck? Let's, for simplicity, let's just keep it like that without any where. Just like that. Simple. It should work. The page. Page. Am I done? Am I done? I hope so. Good. Now, unfortunately, I have to put these back. Okay, one more restart. Am I doing something stupid? No, I don't think so. Good. In the meantime, let's spend time looking at the Glowroot displays over here. And so again, you get the point. This is a jar which you add to your application, and it opens this port 4000 on which it responds to your stuff, right? So, and it also shows you here the GDBC and GDBC get connection. That's it. That's the thing that we'll focus after this exercise. But first, let's look at the queries again. Actually, let's look in the log. That's what oops, it died. It died. Why did it die? Select P from parent P, left join fetch P dot children. Count query validation failed. Damn it. Let's simplify a bit the problem. Let's not use any paging anymore. Just take a list out of there. Nothing fancy, no more pagination for you today. Sorry. And let's just put 20 lines in total in the database. So I'm just having 20 lines in there. Paging should have worked. I wasn't bright enough to make it today, but that's not a problem. I need to see that this will fire a single query to the database. Good. And we only need to talk about GDBC connection starvation next. Let's see this first. So this, when I fire it, a request should not do more than a single query. It does a single query for some reason. It doesn't find anything. Or am I wrong? Am I wrong? Perhaps it's still inserting. That could happen. Select P from parent P, left join fetch P children, and then I am inserting. No. Okay. There you go. It wasn't inserted yet. So this is the response. And if I look in the log, I will only see a single query, not 11 as before, 1 plus 10. I only see a single query. The magic is that now this query left outer joins the children to get the data for the children in the same shot. So one single GDBC hit, one single network hit. Okay, and Glowroot will not display me much more data now because that query is not run in the loop. Good. The next exercise, let's try this. This is a query which takes a long time. We call these fat pigs. Find all should be avoided. Yes, Raj, of course. It's just for demonstration. You probably need to search to filter something, not find all. Either you page or find all only for reference data, the stuff that you know that is limited in size, like the country lists should do find all. That's it. Okay, so we have these queries that occur quite rarely, but they take a lot of time. Glowroot can also spot them because in the queries, there will be here, the average time. This one, am I right? Let's see again. For some reason, it's not taking as much time as I. One more shot. Let's see them. Oh, I think I'm here. I should have clicked all web transactions. This is very interesting. It shows you the SQLs which are run per endpoint. Very useful. Now, this one proves to run in 2 seconds. Now, this is usually something that the DBA will complain about, telling you, oh my God, your queries run too slow. What are you doing over there? 2 seconds. It's very easy for you to trace such cases like this. And it might be just some extraordinary, but here we go. 5 occurrences took 2 seconds each. And only brought 25 rows. Why was that happening? Because I'm searching a table, very big table, without having an index where it should have been. So I'm putting here a where clause here, a where clause that that is not covered by any index. So this results in a full scan in the table, and it takes 2 seconds. It will take much more if that were a larger server. This is like super lightweight in-memory H2. If it was a Oracle, it could take more. I'm not sure, but right. What else? What else can we do here? Not much. We need to go for the last exercise, which will also involve the third set of tools. So Javascript Recorder, you connect with SSH, you activate, you download the GFR recording, you look it, you upload it in Java Mission Control. This one, Glowroot, you put it in your dev environment, in your system integration, acceptance, quality. I'm not sure if putting it in production is a good idea. Not sure. The third tool, however, is used to raise alerts. Now, what am I talking about? The use case is the following. I think I will spend 5 more minutes after sharp. So, okay. So this time, let's focus just on the problem because it's complicated anyway. It's by itself. So this one creates a sheep. Right? Pay attention. You probably have occurrences of such problems in your application today. It creates a sheep, and then after a while, searches for the sheep. Create, search, nothing more than that. Very easy, right? There are, 1,000, let's not exaggerate. Let's put 50 users that are trying to create and then search the entities that they created. All right. Let's put in 50. So 50 users, maybe it's too much, just to even 30, let's do it. Let's start with 20. Let's start with 10. Let's start with 20 or 10 users. If you hit it with 10 users, what happens? If you look in here, you will find that create finishes in an average of 1,000 milliseconds, 1 second. Search finishes in 8 milliseconds, and it's perfectly reasonable, especially after you find out that creating a sheep needs first to register the sheep. I'm not sure if you know that, if you ever spoke to a shepherd in Romania, they sometimes they take a long time to answer. They first scan you, And after 1 minute of silence, they answer you. So this shepherd takes 1 second to respond to your request. Could take 50 milliseconds, or maybe mappings. Maybe the response that is sent back by them, which is a random UUID, by the way, it comes after 1 second of delay. And by the way, my friends, you probably know this one. This is WireMock, and I've instructed WireMock to introduce latency in its responses. So basically, I'm hitting here a REST endpoint that responds after 1 second. All right. So it's natural for register ship to take 1 second, right? Because this one takes 1 second, and after I get the serial number from the shepherd, I can put the serial number into the ship, and together with the name of the ship, to save the ship in the repository, and then we get the ID back. Good. Now, let's see what happens if the number of threads. This is reasonable. This is a reasonable output, right? 1005. It's perfectly reasonable. But let's see what happens if I get not much more, but just a bit more load on my system. What happens then? I cheated. I should clear the results first and then run again. By the way, this is all recorded on YouTube. The recording will be available immediately on my YouTube channel, or I will post it in the meetup also. If I look now, what happens over here? Something is not right. Why is it 100, 200, 200? Why is it? Oh my God! Let's raise the alarm. What happens? What happens? Right? What happens? Why 500 milliseconds? This is not obvious. Not obvious. So let's see. Maybe Glowroot can help us with this one. Create and search. Response time. Right. Not very helpful. Actually, it could help, but it's very. There you go. Come on. How can I increase the size? Okay. A second. I can here. Much better. Perfect. All right. What is this yellow part? GDB get connection. Ouch. This means that your connection is acquired after a latency, but Glowroot, you can't put it to production, right? And if it doesn't offer you any monitoring techniques. So this is where we introduced the last set of tools, which starts with Actuator/Prometheus. Now, I will try to run you through all the key pieces of this technology. You should Google this, and there are people presenting how you can put this to your application. This is a tool you can keep in production, and most of my best clients have a Grafana connected to their production environment, and that raises alerts in their mobile phones or in their Slack channels when something goes wrong in their production. What are the key ingredients? In POM XML, we have to have, first of all, of course, Actuator, but not only Actuator, but also Prometheus, and actually this one, Micrometer and Prometheus. What do these do? Micrometer is a technology which introspects all the, basically monitors the performance of the key components in a Spring. These statistics that are gathered by Micrometer are available to this endpoint. To this endpoint, there will be another system connecting. The system that will pull these statistics on a regular basis, it's called Prometheus. This Prometheus is like a database, basically, which pulls the metrics at regular intervals, typically 15 seconds. It pulls the metrics and stores them. Now, I had them all running for me when I started this Docker Compose. So the Prometheus is running on 1919, and I've told Prometheus to go and scan my 8080 port on my physical machine for this endpoint. So Prometheus is connecting from the Docker back into the host machine, into the physical machine, to this endpoint over here, 8080 Actuator Prometheus. 8080 Actuator Prometheus. Now, Prometheus now has all the data. If I go to 1990, I can actually see that. This is Prometheus. It has its own graphs, but you have to tell it what you want to see. Acquire seconds max, for example. How much time did I ever spend waiting for a connection? I think these are seconds, if I'm not mistaken. 2 seconds waiting for a connection. That's outrageous. 2 seconds. I hope that's seconds. However, people don't use Prometheus to look at the results, but what they do, they use yet another tool, which is called Grafana. Now, Grafana will pull the data out of Prometheus this time, and it allows you to display it in a very nice representation. And it turns out that you can actually add, and you can import a set of, so for example, Grafana connection. There are out there in the wild. There are pre-created dashboards that you can add. So this one, for example, is the code for that is 6083, and I've added this 6083 in my endpoint over here, and now in my Grafana deployment, and I can see the metrics collected from my running system. These are the metrics collected from the connection pool itself, from the Hikari connection pool. What does it display to me? It displays, first of all, active connections 10, pending threads 20. There are 20 threads trying to do stuff with that. It also shows me the acquire time, the acquisition time, which demonstrates that every time that any request wants to go to the database, it has to wait for 1 second, roughly, to get the connection to talk to the database. And after that, the database is used for a very short while. I mean, not really, because you know what? Why we have 600 over here? Because you sleep sometimes. What's important over here is the acquisition time. You shouldn't have this. If you have this, it means that some endpoints which are extremely slow, which are taking hold of the connection for a very long time, are impeding the others which are very fast to perform. Now, what is the reason of all that? Maybe can you already spot the reason? It's in this page. Let's see, a quick poll, a quick question. Do you figure out why am I starving connections? Why? So the behavior is the following. Search wants to do some query to the database extremely fast. Create, however, needs to save. And the create, we know that this takes 1 second. Why is search impacted by that? And you see the problem. There is a lag between us, so let me wait for 5 seconds. 5, 4, 3, 2. Yes, we are running out of connections from the connection pool, but why and how to fix it? Why and how to fix it? Let me see one other try. 5. Yes, transactional on row 3, on row 40, narrow transaction. The transaction that is put on the class is propagated by default on all the methods inside, which effectively means this. Search doesn't really need a transaction if you think. And the problem, however, is not the search needs a transaction. The problem is that the transaction I put over here will freeze the connection for the entire duration of this method. What you can do into here is to think critically, do you really need a transaction over here or you don't? It turns out that you don't, because save has its own transactional inside. So you get a transaction when you talk to the database anyway. The problem was that you were keeping hold of the connection for the entire duration of a REST call. So this is an anti-pattern, calling a REST endpoint while keeping hold of on a connection because you are in a transactional method. There are some geek ways to work around that. There are some flags that you can put. Let me see if I have them already in my. There is some geek flag. No, yeah, this one. If you put this on, you solve the problem even with the transaction on the class level. Vlad Mihalcea told me that. But still, the trick is that transactional should be narrowed to the least amount of code. Okay, and only if you really need to make atomic some interaction with the database, only then you put transactional surrounding those. You don't put transactional on all the stuff. I mean, to be honest, I've put transactional on the service level every time, and I didn't ever have a problem because I was not under serious stress. But I have clients that have thousands of requests per second. They can't do that. They don't have the luxury to make transactional on the whole class. So they will be very, 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 very careful what they transact together. And this can hit you, this can harm you, even if you don't really expect it, because this might respond usually in 10 milliseconds, but sometimes 1 second. And if it suddenly goes slow, your entire system will fall down because you don't have connections in there anymore. All the 20 connections were blocked. Typically, you have 20 connections. They were blocked because you. 20 connections. That's why I chose 30 threads over here, because that's the default connection pool size. Okay, so right now, after I've changed the transactional, the JMeter seems to work still, but here you can see acquire time is not even logged, it's 0, right? Which is very, very, very cool. Now, another thing which you can use this one is to raise alerts whenever something goes bad. And also you can add a panel, for example, here, shepherd. Now, what the heck is this? Shepherd, if you divide shepherd some seconds by shepherd, I will show you what shepherd is, shepherd count. Well, actually, you can put shepherd max. Why not? Let's stick with that. If you add a panel like this, you actually just got the average response time of your shepherd. Okay. Now, how is it possible? How can I have this here? In my application, do you see this annotation? This annotation is an aspect that Micrometer knows about to measure the time that this method took. And I can have a close look on the performance of the other system, and I can raise alerts based on that. I can create alerts based on that. Save dashboard. I don't know. Yeah, I can create alerts. I'm not sure how to do that. It's somewhere here. Alerts. Right? Notification channels. It's quite powerful. It can raise up your entire team. All right, and Discord, Google Hangouts can. Okay. Yeah, Telegram. WhatsApp is not here yet. Good. So you can send you messages when something goes exceeds a certain threshold. Right? Maybe acquisition time, maybe the time of the system that you're calling. And this is a tool you can have in production. Very low impact, because the only thing that your application needs to do is to expose these metrics that Prometheus will collect on a regular basis, not very often. So honestly, this is basically zero impact. The only moment in which you might have an impact if you put annotations like that on methods which are invoked extremely fast, like 1,000 times per second, because this aspect itself has some performance impact. All right, so recap, what did we do? Insane day, huh? This one, you can use GCMD to start stop, or timed auto stop. Okay. Using SSH on production, you can decide the profiles to use. There are two of them. There is continuous. Let me stop JMeter because it kills my machine. Continuous or profile. There are two ways of inspecting, right? This showed us thread local allocation buffer issues and also method profiling with a flame graph. Okay, Glowroot to put in pre-production environment. Okay, looks at SQLs, REST calls. By the way, I didn't look at again at Glowroot after I'm calling the shepherd. If you look at the create and do service calls, you can see that this one takes in average 1.5 seconds. For example, so it's all there. Very nice tool, lightweight, free, lightweight. This is a tool that I would like you all to put to your system to have a look what happens over there. Micrometering out, and one more thing to note over here: the GFR file you load into Java mission control. Micrometer-Prometheus-Grafana, they are good for production. They are for monitoring, alerting. And they basically know about Spring internals, like connection, for example. So this is the advantage. Each has its own advantage. This is very low level. You can put this to any application. This is integrated very good with Spring, but also with other technologies, other containers. Glowroot is something you can put, again, knows about your Spring and about your stuff, and it's very friendly for typical applications. And with that, I think I'm done. I'm told that I am done. Thanks a lot for your time, for your and if you have questions, if I said something stupid, email me. Tell me what, how did I, okay? The recording, exactly. Let me paste my email first in the chat. If you have any questions, any thoughts, this is super advanced stuff. So this is high stuff, hardcore stuff. The recording is on my YouTube channel. My YouTube channel is YouTube. I think that's easiest. But I will also put it in my in the meetup, in the meetup page. Good, that is it. Can you share config for Prometheus and Grafana? Grafana has no configuration custom. Did not do anything with configuration. Prometheus is here. And since you ask, let me create a GIST and give it to you. But it's honestly not a big deal, right? So this is it. Look into the, it will take a while to put everything, look at the recording, try to replay what I did and do it yourself. Remember, you have to start these 3 tools. Database, to have a database next to you, start warm-up to be able to have the shepherds responding to you. And then it really pays to do this exercise later with your team and whatever. Okay, this is the Git location commit that I've done just before at the beginning of today. So look at the time before today, before this started. I'm done. Thanks a lot. Gotta go. Bye, folks. See you next time. Have a nice summer. Enjoy it. Yeah, make the best of it. Who knows what happens in the autumn? So make the best of it today. Bye, folks. Bye. Stop sharing. Good. And end stream. End stream.